Sitting here in my 12-foot aluminum boat. It's got a new transom in it. That's right. Brand new transom. These things are kind of easy, kind of not. And I'm going to tell you about replacing a transom in your small aluminum boat. The good, the bad, the ugly. With the idea of helping you decide what's the best way to do yours in your boat. So we're going to talk about some mistakes. We're going to talk about some costs and how difficult this is to do and what I would have done differently if I was to do it again. And be sure to stick around to the end because I'm going to show you how well this has held up after 2 years. That's right, I shot this stuff 2 years ago, and at the end of this video, I'm going to give you an update what this transom looks like after 2 years. What is the right stuff to use whenever you're replacing your transom wood? I'm replacing the wood from the transom. This wood has been in this boat since this boat was built. I can tell because of the paint that's on here matches the paint of the inside of the boat. Now, this piece of wood clearly needs to be replaced. It's rotting out right here where the motor mounts. It's had some ant intrusion and everything like that. So first off, this original transom is about 1-inch thick plywood. Odds are, from what I've been reading, is that a lot of this old plywood that was used back then wasn't even marine grade plywood. It was just plywood. And maybe this was good for the first 20, 25 years. That's something to think about right there. So there's a lot of people that will tell you the right way to replace this transom and the materials to use to make this thing last forever. However, the cost of that in terms of labor and materials expense is quite high. And I have a different approach that I'm going to take. I'm going to walk through some of the different materials for transoms and why we use or don't use them and why I chose the material that I chose for my boat. So let's talk about the top of the line way that you should go to replace this so that you never have to do anything again. And that is to use a material called Coosa Board. Coosa Board is sort of a synthetic plastic board that is designed for marine use. You can buy a piece of Coosa Board, this is about 4 feet wide, probably only a little over a foot tall, to stick in here in place of this plywood, and the piece that I need costs $226. Yeah, $226. And I'm not sure if shipping is included with that price or not. That to me seems pretty pricey, so then I look to see, okay, what are some of my other options? Marine Grade Plywood. Marine Grade Plywood is considered by many to be your second best option. Cheaper than Coosa Board. Advantage of Marine Grade Plywood is that the adhesives used between the plywood layers are meant to be much more water resistant, I believe. And then also the layers of wood have less voids in them. So I assume that means the less like little chunks that are missing and possible gaps. So therefore, it's sort of a denser, more solid pieces of wood that are laminated together, and therefore making it a better plywood for marine use. I can buy marine plywood for about $70 for the sheet that I need. But of course, the sheet I need is 1-inch thick. I'd have to buy a 1/2-inch thick sheet and still glue it together to itself to be able to make a 1-inch thick piece. In addition, what many people recommend with marine grade plywood is to make it last longer is to seal it in fiberglass resin and a layer of fiberglass. By sealing it in fiberglass and resin, you do increase its potential lifespan. So you're not just buying a piece of marine grade plywood, you're also having to buy fiberglass and resin and spend the time and the money to seal that to make it perfect. The next option I found is Starboard. Starboard. Starboard seems like a synthetic plastic PVC type of board, specifically made for boats. However, I've never heard of anybody using Starboard to do their transom. A piece of Starboard this size would be about $88 plus shipping. I'm not sure if it's well suited for a transom. I haven't heard of anybody using it for a transom. If you've used it for your transom, or you think it would be suitable for a transom, let me know in the comments below. I was worried about Starboard, which made me think of one of my next options that I was considering, PVC board. I had bought some of this PVC board that I used to do the seat backing material in my big boat to replace the plywood, and mounted my seat stuff to that. However, this is kind of flexible and it's 1/2 inch thick, so I'd have to use 2 of them sandwiched together, but it's relatively flexible. So that was something I was considering, but I didn't like the fact that it wasn't quite as rigid as it probably should be. So then some of our next options is pressure treated plywood. Well, you're not supposed to use pressure-treated plywood with an aluminum boat. Apparently, I guess they react. Something to do with the chemicals, I guess, they use whenever they're doing the pressure treating process. So you're not even supposed to use pressure-treated plywood. So then the next option, regular old plywood can delaminate, can come apart where it's been glued, but BCX plywood is rated for exterior use. And it actually has a smooth edge on both sides and is very, very similar to marine grade plywood from what I can tell. And it's a lot cheaper. Matter of fact, I bought this sheet of BCX plywood for under $17. And this one sheet here, this was a 4 foot by 2 foot sheet, I can actually trace out the 2 halves that I need and glue them together. Some people will say is, okay, that's fine, go ahead and use BCX plywood, but wrap it in fiberglass. To put it in resin and in fiberglass, that will seal it up and keep it from getting any moisture inside. If I was to buy the resin and the fiberglass materials to do that, to make it last forever, I'm going to have a whole lot more time and money into this. My thinking is that that original piece of plywood was probably good for 25 years. What I might do is maybe I'll paint it and paint both sides of it with some really good paint. Other than that, I'm not going to do anything at all. And that's going to have cost me under $20 to replace my transom versus $200 and some odd just for a piece of Coosa board. Looking at our 4 worthy options, Coosa Board definitely ranks number 1. It is the highest cost, but it is the highest quality and the easiest labor because basically I just got to bolt that in there. Marine plywood plus fiberglass comes in second. However, the cost is high, almost as high as Coosa Board once you consider buying the materials to fiberglass the plywood. The quality is going to be almost as good as Coosa Board, but the labor is going to be the hardest because of all the fiberglassing time after you cut the wood. So then if we went with regular marine plywood, the cost isn't bad. The quality isn't bad, and the labor isn't bad, but I would probably be painting the marine plywood, which then brings us to the plywood that I'm going to use, BCX plywood. The cost is absolutely the lowest by far. We're under $20. The quality obviously is the lowest when you compare it to these other 3 options. And the labor would be the same as if I'm painting marine plywood. So the option that I'm going with is the cheapest option and the lowest quality. Why not see how long that holds up? If it lasts me a season and then it starts to rot, okay, I've learned a lesson. I've taken this apart. I can take it apart again. It's not the end of the world. It literally took me maybe an hour, tops. I'm going to give it a try. This is my boat. What do I got to lose? What would you use on your boat if you were replacing your transom? Okay, let's go back a few weeks when I started this project. Here is my old transom board in my boat. As you can see from a distance, it doesn't look that bad, but it's original to this boat. You can see from the green paint that's bleeding through underneath of there. And believe me, it's rotten. As we get a little closer, you can see there's some other damage here as well. There's a crack in the aluminum where it attaches across the back on this side, right here, and the same kind of crack on the other side. That has to be dealt with. Here's the handles on the back of my transom, and here's the other screws that go through the transom to hold the transom in place. As you can see, these are just old slot head screws, and that one up there was missing. I don't have anything else on my transom that needs to come off. which makes it a little bit easier for me to do. Going on the inside and taking a look, as you can see, these are all just nuts on this side. Here's the close-up of the wood, and we have this aluminum plate right here where the motor mounts to. You can see where a motor has been tightened down onto that plate. And down here, this is a dogleg brace. This particular boat has a cap that goes all the way across the back of the transom. This will determine the thickness of the new transom board I put inside of it. My measurements, it looks like it's exactly an inch underneath, but I won't know until I get the old transom wood out. So it doesn't look like it's going to be too tough of a job, or is it? Got my trusty tool bucket, which I always like to use for these kinds of things. What I do is load in a whole lot of the tools that I need and bring them out with me. Starting off, we have our slot head screwdrivers. I got some nice big ones and a couple of different wrenches to try to see what size these nuts are on the inside here. And now that I have a wrench and a screwdriver, I'm going to try to take some of these bolts out. At first, I start straightforward with the one that's broken off already, and this end of it just completely spins, because the stud is stuck in there with the nut on that. But I was able to pull that one out, so that one came out cleanly. All of this hardware is aluminum, so while it doesn't rust, it's very soft. And so what happens when you go to try to loosen a lot of this stuff is sometimes it breaks very easily. So you can either strip out the head of the screw, or you can literally snap the whole entire stud. And basically what I encountered is every one of these bolts snapped off instead of actually coming loose. I wanted to be careful not to actually damage the back of the boat, but as you can see, these screws very filled with paint, and so I had to carefully try to scratch the paint out of the slot head of the screws so that I could remove the screws. Luckily, I didn't damage any of the transom trying to get these screws out because they all snapped off. A little bit of gentle tapping was able to free up all of the studs. Even the second transom handle was able to pop off once the nuts were broken free. Now we could go to the inside of the boat, and I wanted to see if the aluminum plate here would come right out, and it did. It slid right out of there, so that's nice. That needs to go back in because that keeps your wood from getting damaged when you're tightening down your motor. And as you can see through there, the wood was quite soft right in the center there, and I was able to just push my finger right through, meaning that yes, this definitely was rotten and in need of repair. So now that I had all of the bolts out, now we encountered our first real major hurdle. The dogleg brace that goes to the floor of the boat was bolted to the back of the transom right through there with those two bolts, but the other part of it is riveted through the floor of the boat from underneath with solid rivets. And I needed to remove those solid rivets or this piece wasn't going to come out. And as you can see from underneath, these are solid rivets that have multiple layers of paint on them, along with all of the other solid round head rivets that are underneath of the boat. Now what I thought at first is I mistakenly thought that maybe I could slide the transom wood down below the top lip and be able to pull it out that way without having to remove the dogleg. That would have been really nice if that would have worked. However, as I carefully tapped down on the board so as not to damage any of the aluminum, trying to slide it down a little bit, I found that that brace was very snug against the transom wood, and there was no way I was going to be able to slide this transom wood out of the boat around that brace without removing the brace. And even if I cut this transom board to be able to get it around that brace, I would still have a problem whenever I went to put in a new transom board. So all of my efforts and wiggling and playing around with it for a long period of time just made me further realize that the only way to do this would be to actually take out that brace. Because those are solid rivets, the only real way to tackle that brace is with a drill. There's those 4 rivets, and I'm taking a nail, and I'm going to use a nail to make a center punch hole in those rivets. Now what you have to be careful about with these is you don't want to over drill these holes and make really large holes where you have to put in really big rivets. So I'm taking a nail and just putting a center punch in each of these rivets. And once I have them center punched, then I can go at them with a nice small drill bit. So I picked a really fine drill bit to drill my pilot hole into these rivets. The idea is by drilling a small pilot hole first where I've center punched, then I can progressively drill a larger and larger hole to be able to drill through enough of the aluminum that's coming through on this side of the boat to be able to knock any scraps of this aluminum away without over drilling these holes. Because if I over drill these holes, it's going to make that bracket weaker and will require me to put in oversized rivets back into the boat. So I start drilling out my pilot holes. And because rivets are made out of a soft aluminum, this goes quite well. And with all 4 of those drilled out, then I stepped up to a larger bit, coming closer to the edge of the rivet, but not going so big that I'm actually damaging any other material. And I don't need to go all the way through the rivet. I just need to go down to where this flanged flat piece is. So I only need to drill down a little ways. Once I had all of them drilled out, then I took my screwdriver and my hammer and I knocked off any of the excess bits that were still around the edge of that, which came off quite easily. And I was able to remove the brace. Once that brace was removed, of course, my transom board just popped right on out. And ooh, look at the back side of that board. There's a lot more rot and insect infestation than you would have thought there would be with that way that board looked on the other side. So I'm really glad I'm replacing this board. Now let's start looking at making the new transom board. So as I mentioned, I'm using BCX Plywood. So I have my piece of BCX Plywood right here. It's 1/2 inch thick and my board needs to be 1 inch thick. I originally actually bought 2 pieces of BCX Plywood thinking I'd need both of them, but laying my old transom on there as a template and drawing it out, and then of course my pencil point breaks, getting another pencil. But once I go to draw this out on here, I realize actually as I start doing it that I can fit both of my sections of my transom on one sheet. So I don't need to have both sheets of this plywood, which is great because that saves me even more money. Then I can start cutting. I set them together, everything lines up, they're nice. So then what I do is before I go to do the angle cuts, I want to have them match on both of these pieces. So I decide to clamp it all together. Then I can do the angle cuts for the bottom edge of the transom boards. By clamping them together, I'm making sure that both boards are cut at the exact same angle. Now I have my 1 inch thick piece of board that I need. So we go to the basement because my wife parks in the garage. Down in the basement, I decided to use liquid nails to stick my 2 pieces together. I've always had good luck with liquid nails. So I spread that on one of the boards, used my gloved hand to make sure it was all rubbed in there really well. So once I got it set in place, lined up just right, I went ahead and put some of my clamps on there to clamp it in place. Put my 4 clamps on there, and then I went and got a couple other clamps just to put on there. And I thought, well, for good measure, I should put some weights on there to make sure it sits on there tight. So I grabbed some paint cans and set them on there, and then did some overkill and put a couple of cabinet doors on top of it. And then left it set. And this is where things went oddly wrong. In the corners where it wasn't clamped, there was a gap. And I've never seen liquid nails fail on me like this. I filled the void with copious amounts of tight bond wood glue and then put several clamps on there to be able to reunite these 2 panels together in these corners where it had separated. Of course, all of this added several days to this project, and now it was time to start protecting this wood. I sanded the board down really well, and I used this Glidden Porch and Floor latex stain that I had on hand. I don't think it's an epoxy. I think it's actually just an exterior grade paint, but it was something that I had on hand and I thought might work good for this. So I would put a coat on one side of the board and around the edges, let that dry for a day or 2, flip it over, do the other side, and I repeated this process several times. So I think in the end I ended up with 3 coats on each side of the board. Remember these cracks that are here on the top of the transom? Now luckily I don't have any holes in my transom that aren't bolt holes, and I don't have any other areas that are damaged on my transom except for these 2 cracks right here. Now the right way to fix these kinds of cracks would be to actually have them professionally welded with doing aluminum welding. As you can see, it's kind of bendy right there, so it broke at that joint. The other side, it's cracked all the way around, and it broke that piece itself. It's not just broken at the joint. So I started by wire brushing all of the surfaces there to get the old paint off and debris. Once I got all those areas all wire brushed, then I wanted to clean them up so that I could try brazing rods. Wiped it down with some acetone to get it good and clean and prepped. And what I tried to do first was I actually got some aluminum brazing rods and tried it with a propane torch because I heard that can work. However, the propane torch can be problematic because it doesn't get the aluminum hot enough. And that's basically what I was dealing with. My aluminum brazing rods I used, I ordered these from Amazon, and as you can see they call them welding wire, no needs solder power, low temperature welding crack repair. As much as I tried to heat it up with the propane torch, I could never get it hot enough for these welding rods to melt along there. They would melt off just into balls and roll away. And sometimes they would glob a little bit, but they just didn't stick. So then I purchased a MAP gas torch because I hear they burn hotter and they work better for these kinds of applications. Here's the results I got with the MAP gas torch. They're not great, they're not beautiful, but I was able to get some blobs to reconnect those pieces of aluminum. And that's really all I got out of it, was I got some blobs. And those blobs are strong enough that is all now one piece. It's firm, it's solid. If I wanted to, I could file that down probably. I might be able to get a couple more blobs. This one actually is kind of a pretty good bead, except for my blob on the side there. So once I got that done, that was all now brazed up and I painted it all. So I just repainted this with some gloss white paint real quick. Didn't really spend a whole lot of time redoing it, just sort of painted everything, and now it looks a million times better. And as you can see, these look a whole lot better even just with some paint on there. So now we're ready to actually install our transom board. Now I think this is going to hold up for a very long time, especially since I painted both sides of it with several coats and sealed up every place where moisture could get in. So we've got our board completely ready to install. I mean, it looks great. It really turned out fantastic. So let's look at some of our tools we need here. Well, one of the things I brought out was some clamps because I need to be able to hold this board in place when I go to start drilling the holes. Got my wrenches, got my bag of new stainless steel hardware, my brand new aluminum handles. I bought all brand new stainless steel hardware. The idea is that these bolts will go through, and on the outside of the transom I'll use this flat washer just to spread the weight around a little bit so the bolts don't dig into the back of the boat. And then on the inside where the wood is, I'm going to use this bigger flat washer. That way it spreads the load out, doesn't crunch into the wood. And then I like locking nuts, or locking washers. I like locking washers. So then we put a locking washer on and a stainless steel nut. And that's how they're going to be going through the transom. Just like that. Now I also got longer bolts to go through where the handles are. I don't need a washer on the outside of those, but on the inside of it, I'll need to have a big flat washer, and then a locking washer, and then a stainless steel nut. These longer bolts should penetrate as far through as the other bolts do whenever everything is finished, so all my bolts will stick through evenly. So we need 6 of these going through various areas of the transom, and we need 4 of those to go through the handles. Screwdriver that I'm going to use for mixing up my JB Marine weld, and then of course my drill with the right size drill bit to drill the holes for the bolts, same size as the old holes. I cleaned up the surface. I probably should have painted this or primed it or something like that. And then we test fit the panel in here. I hadn't done this before actually, and thank goodness it fits. I held it up high and clamped it in place. By clamping it in place, that allows me to drill my holes through the existing holes. Now out at my boat, I've already started drilling some of the holes, and I actually stuck a couple bolts in there just to test them out. And then I just here mixed up some JB Weld Marine Epoxy. The JB Weld Marine Epoxy that I'm using is how I am sealing up the places where I'm drilling through the wood of the transom. And that's one of the things I don't like about marine plywood, because even if I was using marine plywood, I'm still drilling holes. And if moisture gets into that hole, that's where it can rot the wood. And we have to drill several holes through this thing. So the way I'm sealing it up is I'm using JB Weld Marine Epoxy. And I'm coating the bolt with that, And then I'm also putting it on both sides of the washers. Now, why this is important is because on the outside of the boat, I'm using stainless steel hardware going into the hull. That stainless steel hardware is not supposed to be touching the aluminum because of galvanitic corrosion, I believe. Because these are dissimilar metals, you want to have something between them. And that's where this JB Weld Marine Epoxy comes in. So it will seal moisture from coming in through these holes, and it also keeps the stainless steel from touching the aluminum. And on the inside, same kind of thing where I'm using the epoxy to help seal up the bolt hole. You don't have to use what I'm using. You could use something like 3M 5200 or some other kind of epoxy or sealant. Basically what we're trying to do here is keep the stainless steel hardware from pressing up against the aluminum, and also to seal out any moisture from getting into this transom wood. Once I had a few bolts in, I could remove the clamps, and then as you can see, I've now got the bolts through with the top aluminum piece in there, mixing up a bit more JB Weld to get some of the other bolts going through. And now I'm putting the bolts through where the leg goes in. So these are the bolts, and then I'm putting plenty of extra JB Weld epoxy on the inside of those bolts where they come through there, because this is where the dog leg brace goes in. So what I'm doing is getting the bolts in there. I couldn't use the big flat washers on this side, so because of the angle of the bracket, so I actually used the big flat washers on the outside and the small washers on the inside for that particular section. And as I get all of these bolts and hardware in there, I am snugging them all down evenly with plenty of the JB Weld epoxy on each of the bolts to help seal up my holes. The last thing to go through the transom are the handles, and I'm doing the same thing here, using the JB Weld epoxy on where the handle touches the boat, even though they're both aluminum, and then also on the outside where the bolt goes through the handle, making sure I have plenty of that coating all of my surfaces. And now all the bolts are in place, and as you can see, there's plenty of the JB Weld epoxy oozing out around the washers, and it's looking really good. And here it is from the outside, and you can see the same thing happening here. It's a little bit of JB Weld epoxy oozing out from every one of these bolts. Actually turned out really good. I was really happy with how this went. I also put a little bit of JB Weld epoxy around my seams where I had brazed them up. And with the dog leg brace, what I did is I set it into the floor of the boat and temporarily put 4 rivets through from above just to hold this brace in its correct location. I'll be having to remove these things and actually put the rivets through from underneath, and that's what we're going to talk about next. Those rivets. This was one of the biggest challenges of this whole project, was dealing with these rivets, because there's a pretty steep learning curve with what you need to be able to replace rivets, and the tools you need and the skills you need to do it. If I was trying to do this quickly and cheaply, I would have replaced those 4 rivets that went through the floor of the boat for the brace with stainless steel bolts, thicker stainless steel bolts that were the right diameter to go through there, nice and short, and put a whole lot of that Marine JB Weld on there and tightened those down, and I think that would have worked absolutely fine. But once again, just like with the MAP gas and the torch, I wanted to try to see what it was like working with these solid rivets. And here's how it turned out. As you can see, there's my rivets all finished up. I didn't record me putting them in because it was very difficult to do this and record. Here's some existing rivets, and you can see how they look, and here's how mine look. And if we go to the other side, you'll see the same kind of thing. You'll see a couple of existing rivets in here, how they finished off, and how mine finished off. Not too bad, I don't think, for my first attempt. I sealed it up underneath really well with a lot of that JB Weld epoxy, and I had that on the inside as well underneath of those rivets. So my rivets turned out pretty good. I don't think they're going to leak, and I don't think my boat is any less seaworthy for me putting those rivets in than it would have been if I had gone any other route. All right, let's talk about the cost of materials. Here's a breakdown of all the cost of materials for this project. I spent $17 for the small sheet of 1/2-inch thick BCX plywood. The handles that I purchased after tax from Amazon came up to a total of $17 as well. The stainless steel hardware, which was the most expensive thing, ended up costing me $35. The JB Weld Marine Epoxy cost $7. And for my metal repairs, the brazing rods cost me $11 and the MAP gas torch costs $50. For riveting, the rivets cost $14 and my rivet setting tool costs $14. If I didn't need to rivet it and I didn't braze it, I got away with it for well under $100. My final thoughts with all of this. If I really wanted to fix this boat to be better than new so the transom would never be an issue, I would have definitely spent the money to have a professional weld up those cracks. I spent way too much time and money on an inferior repair for the metal work. I probably could have found somebody maybe who would have done the whole thing for less than I even spent to get the materials for my metal work. But I also don't ever intend to hang a really heavy outboard on there, so I feel pretty confident that my transom is much better than it was when I bought this boat. I'm really happy with the hardware choices I made. I like the stainless steel bolts, but I also could have easily just bought 4 more stainless steel bolts, wider ones, to be able to use in the floor, and I wouldn't have had to deal with any of that rivet stuff. So once again, that would have been a lot easier, and those 4 bolts would have cost a lot less than $28. Now, I did get some satisfaction learning how to work with the rivets, and I'm not afraid to replace rivets in my boat anymore, so I think that counts for something. As far as the actual transom material, I'm still not convinced that marine plywood would give me any better results than what I did. Everybody says it needs to be sealed and treated, so I would have still had a lot of prep work in getting marine grade plywood to work in my situation. And then of course, you're drilling right through it, so you're exposing wood again when you're drilling through there, which you're relying then on your sealers to be able to hopefully keep any moisture from getting into your wood. So Coosa Board in this situation really would be a great choice to provide a lifetime of peace of mind. And it would just be $200 more. If you didn't have to do any metal repairs and you didn't deal with rivets and you were using Coosa Board, you could do this whole project in an afternoon. Instead of, I spent weeks working on this project. So I replaced this transom 2 years ago. And how has it held up for 2 years? Well, here's what you can see right here. First of all, the areas where I brazed, didn't actually weld them, I brazed them, they're holding up okay, but some of the cracks are coming back through again. However, I don't feel like this is damaging the integrity of the boat at all because the transom wood is so strong and I'm not running a really large heavy outboard on here. As far as my piece of wood goes, it's holding up just fine. Now, I have not gone out of my way to do anything extraordinary to protect this boat. Sometimes it sits out here uncovered in my yard for months at a time, and sometimes it's covered. Sometimes there's water in it, sometimes there isn't. However, this transom wood looks just like it did when I put it in 2 years ago. The edges are fine, it's not soft, the paint isn't flaking or chipping, everything is holding up fine. All of the places where I mounted it using the JB weld and the stainless steel hardware are all holding up just fine as well, as are the brand new handles that I put on here. I've actually just recently sold that boat, so I don't have the boat anymore. I only have 2 years worth of data, but when I sold it, it was still looking just fine. Whether or not this BCX plywood is going to hold up for 20 years remains to be seen. I didn't do anything extraordinary to try to take care of it, but I still think it's holding up quite well, and I think it will hold up well for many more years. As far as what you should do for your boat, it really depends on what your budget is and how long you want it to last. Anyway, thank you so much for watching. Please feel free to comment down below, and here's a video YouTube has picked for you. Check this one out. It's a good one. Is there enough room for it? Is it there?